Welcome to TigerFest 2019. We are just looking at some resistors. These are Chinese resistors, I'm taking it.
Believe so, yes.
And I wanted to see if they're really half-watt resistors or not. And so I was figuring out what I was doing here. 10 volt, first we had a 10 ohm resistor out, which we've already cooked. And I did the math after the fact. 10 ohms with 10 volts on it, give you 1 amp. So that would yield 1 watt. These are half-watt resistors, obviously it would fry. We actually had about 7 volts on our meter because the power supply I'm using just has the trouble going much lower than that. Not a very good power supply. So that yielded 700 milliamps, and times the 7 volts again. Of course, you could do the good square and then divide, but anyway, yields 49 watts, or 4.9 watts. So we switched to a 51 ohm resistor, and I did a little mathematics here. Okay, so here I'm just trying to find out what current is doing for X voltage across a 51 ohm resistor. And it's simply the voltage divided by the resistance. Here, I just grabbed a half watt because that's what the resistors are rated for, is a half watt. So this is why I'm arbitrarily putting that in there. And then here's my formula for wattage for the other side, which is basically the same thing we calculated here for current, and then times current again, or times voltage again, I'm sorry. So it ends up being voltage squared over resistance, which is your basic power law if you look at your little circle thing. So that's all pretty standard stuff. I set it to half watt just to see what it would be for a half watt resistor. Calculated out, ended up with X squared equaling 25.5, square rooted it, 5. So we're going to look for 5 volts. This resistor ought to be able to hold 5 volts basically indefinitely. And then if we want to burn it, we can hit it hotter and lower. I also want to look real quick before we do this at what happened to the resistor that we burned up thoroughly. I'm betting that it probably still measures pretty close, but it really was way, way over what it could tolerate.
Yeah, we don't want zero resistance.
Yeah, I almost didn't flip the leads over, and that would have been a bad deal here. This meter's got a flaw of being hard to read like the early blue ones were. Wow, see that? Still almost measuring correctly after all the current we put it through. This resistor is well cooked. I'll try to get a magnified view of it in a sec here. So that's a real nice thing about metal film resistors, is they really hold up well, even when they're scorched. You wouldn't want to leave this in an amplifier, even if it measured correctly, because you're worried about moisture attacking the metal. It's no longer sealed like it was, and it may degrade on its own from here. So you wouldn't want to trust a resistor like this. But yeah, it's measuring within spec, even though we, tripled the power or something crazy like that. So we wasted a whole lot of time setting this up again. And I think I fried the fuse in this meter. That's what's taking so long to figure out. Anywho, I did what I normally like to do, and that's put a resistor in series and just use the voltage across it. This is just a 1 ohm resistor we got in series with the 51 ohm we're trying to test. So this is reading current directly, even though we're reading millivolts, because it's across a 1 ohm resistor, so it's just the same reading. And we've had this 7.6 volts going through for quite a while. It's kind of stinking in here a little bit, but it hasn't really turned too brown. It's darkening a little bit. But we're way overloading this resistor. It's way over half a watt. So I guess if we multiply it together, it's about 1.2 watts.
Yeah, standing up well to over a watt, though.
It is standing up. It's sneaking a little bit. Oh, that's only a half watt resistor, so we're way over double. Yeah, so that's standing up very well. Well, it just goes to show how durable metal film resistors can be. We kind of forgot about it and left it burning here for another 20 minutes. It's pretty black now. Well, it's not that black. You can see the bands. It's very dark. It's starting to stink, so we unhooked it. But it's held up. I bet if we measure the resistance, it'll be correct. So that resistor's been cooking for quite a while. It's kind of dark now. It's stinky. What will she measure? It's a 51 ohm resistor. She is well within tolerance. Look at that. Wow, that's almost That's pretty good for all that cooking.